Next problem, Poisson variable has a double mode at x is equal to 2 and x is equal to 3. Find the maximum probability and also find p of x greater than or equal to 2. So first what they mentioned in the problem. So Poisson variable. So it means random variable capital X which is Poisson. So Poisson variable has a double mode. So double mode, or simply we can say that bimode. Okay. So double mode, bimode. Already we discussed this one. So Poisson distribution having a bimodal. Okay. So what are those two modes? Lambda minus 1 and lambda. Here it is. They give it a specific values at x is equal to 2 and x is equal to 3. Next, what they asked to calculate here, find the maximum probability and also find p of x greater than or equal to 2. So p of x greater than or equal to 2 means simply how can I write this one? 1 minus p of x less than 2. So why? Because there it is having r equal to, here we should not include r equal to. So 1 minus p of x less than 2. Simply what we can write here it is p of x is equal to 0 plus p of x is equal 1. So these are the things we are going to calculate. So here already they mentioned this distribution is a Poisson distribution. Then obviously which formula we have to apply here? E power minus lambda, lambda power x by x factorial. Okay. So e power minus lambda, lambda power x by x factorial. So here already in place of x we have 0 and 1. Okay. And next we are going to calculate lambda. Here it is. By for that they gave here it is having a double mode. It x is equal to 2 and x is equal to 3. Simply you can compare these two. If you compare this one, see got this one or not. X is equal to lambda minus 1 and x is equal to lambda. So got the same one, see. It means what about lambda? So lambda is equal to how much? Lambda is equal 3. So just we can compare this one. So x is equal to lambda, x is equal to 3, x is equal to lambda minus 1. It means 3 minus 1, if you write that one, x is equal to 2. Okay, so lambda also we know that. Then we can find this p of x greater than or equal to 2. So here it is, they mention a Poisson variable has a double mode. It means if it is a random variable and in that it is a Poisson variable, and we are representing that is nothing but x is a Poisson variable and it is having a double mode. So double mode, or simply we are saying as bimode. Okay. So in that already we discussed. So a random way, a Poisson random variable having a double mode at x is equal to lambda minus 1 and lambda. And based on the given information, we are comparing these two. So x is equal to lambda, x is equal to lambda minus 1. Then lambda is equal to 3. And then we are going to calculate maximum probability along with that p of x greater than or equal to 2. For how to find p of x greater than or equal to 2, we are writing as 1 minus p of x less than 2. So since sum of the probabilities is equal to 1. So why? Because we know that p of x is equal to x less than 2 plus p of x greater than or equal to 2. P of x greater than or equal to 2 is equal to 1. So P of x less than 2 plus P of x greater than or equal to 2 is equal to 1. We require this one. So for that we are taking this one into right side. So 1 minus P of x less than 2. Okay. And x less than 2 means simply what we are writing. This is nothing but simply 0, 1, 2. Okay. So less than 2 means what we'll get? 0 and 1. So 0 and 1. So this is a Poisson one. So for that we are using e power minus lambda, lambda for x by x factorial. Okay. Now go to the solution. Okay. Next, first given Poisson distribution is bimodal. Okay. So that one we wrote as is what they mentioned, double mode or bimodal, and two modes are. So we said bimodal. Bi is nothing but 2, so that's why here we wrote 2 modes. at the points x is equal to lambda minus 1 and x is equal to lambda. Okay, so this is already we proved. So how to find more for Poisson distribution? Okay, next we know that, so since given that the two modes are at the points x is equal to 2 and x is equal to 3, so therefore lambda is equal 3. So how we got that one? Simply we can compare that one with the above one. Okay, so here it is, see that x is equal to lambda, here it is, and x is equal to 3. So if you compare these two, in place of lambda, so in place of lambda what we have here? 3. So for that lambda is equal to 3. And next in the same way here it is x is equal to 2. So x is equal to 2 means how can you write this one? 3 minus 1, and this one or not. So x is equal lambda minus 1. So 3 minus 1. So x is equal to 2. So from this simply we are writing as lambda is equal to 3. So lambda value we got it. Okay, for applying Poisson distribution, what is the parameter? Lambda. So we require that value of lambda. For that we calculated lambda value by using the given information. Next, next p of capital X is equal small x, which is equal e power minus lambda, lambda for x by x factorial e, and we substituted in place of lambda as 3. Why? Because we got the value lambda here. So for that we substituted in place of lambda as 3. So here is lambda, in place of lambda we substituted, and here also lambda. So for that in this place also we substituted 3. So 3 power x by x factorial, where x is equal 0, 1, 2 and so on, and lambda obviously greater than 0. Now we require the maximum probability. Okay, so for that here it is, so at x is equal to 2, at x is equal to 3. Okay, they mentioned. So at these 2 points we are calculating and we are adding those two, then we get the maximum probability. So here it is, that's why we calculated p of x is equal to 2. So simply we substituted in place of x as 2. Okay, so e power minus 3, 3 square by 2 factorial, which is equal 9 by 2 e power minus 3. And next in the same way p of x is equal to 3. E power minus 3, 3 cube by 3 cube. So which one we are applying the formula? E power minus lambda, lambda power x by x factorial. So this is the formula we are applying. So which is equal to what? P of capital X is equal to small x. So P of capital X is equal to small x. Just by using this formula, we are substituting in place of lambda as 3, and next in place of x as what they give, x is equal to 2, and here it is x is equal to 3. So those things we substituted simply here. E power minus 3, 3 square by 2 factorial. 3 square is nothing but here it is 9. So that's why 9 we wrote here, and 2 factorial is nothing but 2. So this is as it is, and e power minus 3, e power minus 3. We didn't change anything in that. Okay. Now p of x is equal to 3 is equal. Same here it is, in place of x what we are going to substitute? 3 we are substituting. So e power minus 3, 3 cube by 3 factorial. So 3 cube is nothing but what? 27 by 3 factorial is nothing but 6. Okay, so we are getting 3 factorial is nothing but 3 into 2 into 1. So here it is, by cancellation of this 3 2's and 3 9. So for that here we wrote 9 by 2 into e power minus 3 as it is. We didn't change anything in that one. So therefore the maximum probability or the required probability is equal, simply p of x is equal to 2 plus p of x is equal to 3. So here it is, p of x is equal to 2 plus p of x is equal to 3. So why? Because they mentioned at specific points 2 and 3. So simply we substituted here. Here p of x is equal to 2. How much we got it? P of x is equal to 2 is equal 9 by 2 e power minus 3. and this is also p of x is equal to 3. We got it as 9 by 2 e power minus 3. So those two we substituted here, and we can simplify this one. So this is equal 9 by 2 is the common one, and e power minus 3, e power minus 3 is nothing but 2 e power minus 3. So then 2 to both will cancel. So this is equal to 9 into e power minus 3. So by using calci, you can find this value. Okay. So calculator you have to use, and then you can write the value. Okay. So this is maximum probability. Next, what we have to go, what we are going to calculate, p of x greater than or equal to 2. Okay, so what we said, just what we explained, that p of x greater than or equal to 2 is equal, simply we are writing as 1 minus p of x less than 2. So this is equal 1 minus p of x less than 2. So x less than 2 means what we'll get? 0, 1. Okay, so less than 2. So here it is 0, 1, 2. So what is the meaning of this one? X greater than or equal to 2 means 2, 3, 4, 5 and so on. Okay. So this is x greater than or equal to 2, and this is x less than 2. So x less than 2 means what are the remaining one? 0 and 1. So those things we write over here. P of x is equal to 0 plus p of x is equal 1. So this is equal to 1 minus p of x is equal to 0. Simply what we can write? So just we are substituting the values in the formula in place of x. So what is the formula here? It is e power minus lambda, lambda power x by x factorial. So this is equal p of x is equal to x. So this one we are writing. So now you can compare this one with this one. So in place of small x, what we have here is 0. In the same way, in place of x, here it is having 1. Okay, just we substitute in the formula. So 1 minus e power minus lambda, lambda power 0 by 0 factorial plus e power minus lambda, lambda power 1 by 1 factorial, since x is equal to 1, and we know the value of lambda. So what about lambda? So lambda is equal to 3. So that lambda we can substitute here. So this is equal 1 minus, in these two terms which one is the common one? E power minus lambda is the common one. We can write outside, and directly I am substituting in place of lambda as 3, and in place of this one simply what we can write? 1. Why? Because anything for 0 is 1, and 0 factorial is also 1. So for that 1 plus, and next here it is, this one we wrote outside, just we took common, and next here it is lambda power 1 is nothing but lambda, and 1 factorial is nothing but 1. So lambda is nothing but how much? 3. So 1 plus 3. It means what will get the value here? 1 minus 4 into e power minus 3. So then we got it as p of x greater than or equal to 2. Okay. Now we are going to simplify this one. See here, 1 minus e power minus lambda, 1 plus lambda. So just we substitute in place of lambda as 3. And then we got it as 1 minus 4 e power minus 3. So which is equal 0 0.8008. Okay. So what we did here, they gave two modes. Okay. By using those two modes, what already we know the modes of Poisson. Just we chosen that, and we compared those two with the given information, and from that we calculated lambda, and next they asked to find maximum probability. So for that, at x is equal to 2, at x is equal to 3, we calculated, and then we added those two. Then we got it as maximum probability. And next another one they asked p of x greater than or equal to 2. So which one we wrote it as 1 minus p of x less than 2. And by using Poisson formula, we simplified this one. Okay. So this is first one. And next question, if x is a Poisson variable, so x is a Poisson variable such that, so that is satisfying one condition. What is that condition? P of x is equal to 0, p of x is equal to 1. So it means that in another word simply we can write this is p of 0 is equal to p of 1. Okay, so p of 0 is equal to p of 1. Find P of x is equal to 0. So first we need to calculate P of x is equal to 0. And using recurrence formula, okay. So here it is, first we need to calculate P of 0 by using the Poisson variable formula. After that, we have to use the recurrence formula, find the probabilities at x is equal 1, 2, 3 and 4, 4 and 5. So x is a Poisson variant such that P of 0 is equal to P of 1. Find P of x is equal to 0. How to find this one? Simply we use the formula e power minus lambda, lambda power 0 by 0 factorial. So this is the formula we are using. And what about lambda? Did they mention in the problem? No. So by using this condition, so P of 0 is equal to P of 1. Using that, we have to calculate the value of lambda. So lambda we get it, and here in place of small x we can substitute 0. Then we get the first one. And next we have to use the recurrence formula. By using recurrence formula, we have to find the probabilities. So that is nothing but we have to calculate P of 1, P of 2, P of 3, P of 4 and P of 5. So P of 4 and P of 5. So these are the probabilities we need to calculate at x is equal 1, 2, 3, 4, 5. Of course, we can calculate directly also. When? If they don't mention this formula. If they don't mention recurrence, then we can find all these things by using the formula e power minus lambda, lambda power x by x factorial. By using this, we can calculate all these things. But here they specifically mentioned we have to use recurrence formula and then find the probabilities at different values of x, and those different values are 1, 2, 3, 4 and 5. Okay, so let us see that. So here it is. First we wrote what information they gave in the problem. So x is a Poisson variate, and by Poisson distribution we can write P of x is equal e power minus lambda, lambda power x by x factorial, where x is equal 0, 1, 2 and so on. And next, given that condition they gave. So what is the condition they gave in the problem? P of 0 is equal P of 1. So P of x is equal 0 is equal P of x is equal to 1. So here which formula we are going to apply? So P of capital X is equal small x. So which is equal e power minus lambda, lambda power x by x factorial. So this is the formula we are going to apply. So e power minus lambda, lambda power x by x factorial. Okay. So this is P of capital X is equal small x. Now in place of small x, what we have? Just you can compare this one, x is equal to 0. And here it is x is equal 1. So it means in place of x we have to substitute 0 in first one and second one 1. Okay. So that's that one we substituted here. See that e power minus lambda, lambda power 0 by 0 factorial, which is equal to e power minus lambda, lambda power 1 by 1 factorial. So lambda power 0 by 0 factorial is nothing but how much? Here it is 1. Anything for 0 is 1 and 0 factorial is also 1. So for that e power minus lambda, which is equal lambda e power minus lambda. Here e power minus lambda, e power minus lambda both will cancel. So what about remaining? In this only here is having 1. So in right side which one is the remaining? Only lambda. So it means lambda is equal to 1 and which is greater than 0. Okay. So this is the condition we used for calculating the value of lambda. Okay. Got it? So lambda value we got here. And by you taking this value, we are going to calculate P of x is equal to 0. And by using recurrence formula, we are going to calculate 1, 2, 3, 4, 5 of probabilities. Okay. So see the first one. First we calculated P of x is equal to 0. So same like as previous one, e power minus lambda, lambda power 0 by 0 factorial. and this is nothing but 1. So 0 factorial is 1 and lambda power 0 is also 1. And what about remaining? E power minus lambda is the remaining one. So for that we substituted in place of lambda as 1. So this is equal to e power minus 1 and the value of this one is 0.3678. You should write the values. You should not leave as this. Why? Because here we are calculating probabilities. So did you get the probability value lies between 0 and 1? So that is the important one. So using calci you need to find these values and you have to write here. Okay. Next, this is we got it as p of x is equal to 0. Now we are going to calculate p of x is equal to 1, p of 2, p of 3, p of 4 and p of 5. So for calculating those things, which one we are going to use? Recurrence formula. So they said we have to use recurrence formula. So what about recurrence formula here? P of x plus 1 is equal to lambda by x plus 1 into p of x. Already we proved this one also. P of x plus 1, p of x we chosen. By dividing those two, we got this one, lambda by x plus 1. Okay. Now by taking this one, we are going to calculate p of 1. So p of 2, p of 3, p of 4 and p of 5. So p of 3, p of 4, p of 5. So these are the values we are going to calculate. But here it is p of 1 we require. For getting 1 here, what we have to substitute in place of x? In place of x, what we have to substitute? 0. So by substituting x is equal to 0, we get p of 1 in recurrence formula. In the same way, for getting p of 2, we have to substitute in place of x as 1. Why? Because 1 plus 1 is equal to 2. So for that, in place of x we have to substitute 1. And here it is, in place of x we have to substitute 2. And next, in this we have to substitute x is equal 3 and in this x is equal 4. Okay. So by substituting these values and by using lambda, we can get p of 1, p of 2, p of 3, p of 4 and p of 5. Okay. So let us see that. First one, p of x plus 1 is equal to lambda we substituted here. Since lambda is equal to 1, so for that 1 by x plus 1 into p of x. So as per the problem they already mentioned, so p of 0 is equal to p of 1, right? In the problem only they only mentioned p of 0 is equal to that one. So p of x is equal to 0 is equal p of x is equal to 1. They mentioned in the problem, right? So for that simply already we calculated p of x is equal to 0. So for that we equated p of 1 is equal to 0.3678 and we make a dot here. So p of 0 we used to calculate e power minus lambda, lambda power x by x factorial. This one we used. But here it is, p of 1 means we are going to use recurrence relation. Okay, so what about recurrence relation we chosen here? P of x plus 1 is equal lambda by x plus 1 into p of x. So we use this one. Okay, so how can you say that both are equal? See, here is by calculating p of 0, we got there 0.3678. For calculating p of 1, what we have to substitute in place of x? 0 we are substituting. So if we substitute 0, p of 0 plus 1. So 0 plus 1 is nothing but 1 and lambda already we calculated, that is also 1. So 0 plus 1 into p of 0. And then, so simply what we got it here, see that p of 1 is equal 1 by 0 plus 1 is nothing but 1. 1 by 1 is 1. So it is equal p of 0. Okay. So got it here, p of 0 is equal p of 1. Either you can use this or you can use this. We got p of 0 is equal, p of 1 is equal 0.3678. Okay. Now we are substituting x is equal to 1 in equation 1. So in equation 1 is nothing but this one. So recurrence formula, this is equation 1. So by substituting in place of x as 1, see, are you getting 1 plus 1 is nothing but 2. So which is equal lambda is nothing but 1, and next in place of x we are substituting 2 1. So 1 plus 1 is nothing but 2 into in place of x as how much we substituted 1 p of 1. So for that which is equal 1 by 2 into already we calculated p of 1, that one we substituted here, and by simplifying that we got it as 0.1839. Okay. In the same way, next we have to substitute in place of x as 2, and next in place of x as 3, in place of x as 4. Up to 4 we have to substitute. See, by substituting p of x is equal to 2. Okay, so we got it this one or not? So what is the formula here? It is p of x plus 1 is equal to lambda by x plus 1 into p of x. So this is the formula we are using, right? So p of x plus 1 is equal to lambda by x plus 1 into p of x. So here we are substituting in place of x as 2. So here 2 plus 1 is nothing but 3. So for that p of 3. Next, lambda is nothing but 1. So 1 is substituted. Next, x is equal to 2 plus 1 is nothing but 3. And next p of 2. Okay, p of 2 already calculated. So 1 by 3 into p of 2. Then we get it as 0.0613. In the same way, next we are substituting in place of x as 3. So in place of x we are substituting 3. 3 plus 1 is nothing but 4. And lambda value is 1. So 1 as it is. And 3 plus 1 is nothing but 4 into p of 3. So p of 3 is 0.0613 by 4. We got it at 0.015325. So calculation part, so much we have. So calc is mandatory for everyone. Next, put x is equal to 4. What will get? P of 5. 4 plus 1 is nothing but 5. So p of 5 is equal to lambda is nothing but 1, and 4 plus 1 is 5 into p of, in place of x we are substituting 4. So this is equal to 1 by 5 into p of 4 is nothing but 0.015325, and then we'll get the value. Okay, so this is p of 5. They asked at x is equal to 5. So up to 5 they asked. So for that we got it as p of 5 is equal to 1 by 5 into p of 4. So 1 by 5 into what we got the value we substitute. Okay, that's it. So it means if they mention specifically use recurrence formula means we have to use that recurrence formula, and we have to calculate different properties, not only up to 5. So we may calculate up to 100 also. Okay, so for that's why we are calling this is recurrence formula. For various values of x we can find the probabilities by using recurrence formula. Okay, now next block. PDF binomial Poisson distribution for the following data and calculated the expected frequencies. Calculate the expected frequencies. Of course, already in binomial distribution, we got PDF binomial distribution. Okay. PDF binomial distribution, there we did. So what is meant by that? We are calculating expected frequencies which are nearer to the observed frequencies. This we will calling as observed frequencies, and these are the outcomes. Okay, 0 outcome, 1 outcome, 2 outcome, 3 outcome, and 4 outcome, and respected frequencies. At x is equal to 0, the frequency is 109. At x is equal to 1, at x is equal to 2, at x is equal to 4, the frequency is 1. So these are we called as observed frequencies. But we are going to calculate expected frequencies. Fitting is nothing but just we are going to calculate expected frequencies which may be nearer to the observed frequencies. That only we are saying theoretical distributions, okay, or probability distributions. Okay, so how to find that one? Okay, how to find? First we require mean. So same like as binomial. First we need to calculate mu. So mu is equal summation xi into fi by summation fi. So this one we are using, right? So they are also same. So first sum with xi fi. How will get this one? So we need to multiply this one and add all this thing. It means 0 into 109 plus 1 into 65 plus 2 into 22 plus 3 into 3 plus 4 into 1. After calculating, so we have to add all those things, then we get the numerator. And next summation fi is nothing but we need to add all these frequencies. That is, in other words, we are writing as capital N. So capital N is equal summation fi. Then we get some value, mean mu. But here it is, we are saying Poisson distribution. What is the mean of the Poisson distribution? Lambda. So mean mu is equal lambda. So we have to compare these two. Both LHS are equal. We can equate the terms of RHS. So for that, lambda is equal some value we'll get. And next, calculate the expected frequencies. So for the frequent calculation of frequency, what we are using? Capital N into P of X, where P of X is equal nothing but what we are using? E power minus lambda, lambda power x by x factorial. So this is the frequencies, sorry, P of x we are using. It means first we need to find P of 0, P of 1, P of 2, P of 3 and P of 4 into capital M. So how much we got at capital M? You need to multiply that. Then we get expected frequencies. In that expected frequencies, frequencies always must be integers. So after getting the expected frequencies, we need to round off those numbers. Okay. Then we got the expected frequencies. Okay. See that one we did here or not? Same what we discussed. First we calculated total frequency. Capital N is equal summation F5. So all these values 109 plus 65 plus 22 plus 3 plus 1. So N is equal 200. So total frequencies N is equal to 200. Now summation F5. So that one we discussed or not? 0 into this one plus 1 into 65, 2 into 22 plus 3 into 3 plus 4 into 1. So total how much we got it? 0.61. So this is the mean value we got it. But actual mean of the Poisson distribution is mu is equal to lambda. Here we got the value of mean mu is equal 0.61. If we compare these two, so lambda is equal to how much? 0.61. So lambda we calculated. Okay. So after getting this, we need to find P of 0, P of 1, all this. So here we are using Poisson. So for that, e power minus lambda, lambda for x by x factorial. And we represented this total one in a table notation. Okay. So here it is, first 0, and this is already they gave in the problem. Okay. So we didn't bring this one from anywhere. So this is already they gave in the problem. Okay. So that here first we wrote as this x they gave in the problem and frequencies they gave. And next we require P of x. So for that we are substituting different values: P of 0, P of 1, P of 2, P of 3, P of 4 and P of 5. And next capital N into P of x. So capital N into capital N is nothing but 200. So for that we substituted in place of capital N as 200. Next we require these probabilities: P of 0, P of 1, P of 2, P of 3. So what about P of x here? E power minus lambda, lambda power x by x factorial. So e power minus lambda, lambda power x by x factorial. So here it is, first we substituted in place of lambda, already we got it. So how much we got it? Lambda 0.61. So this is the lambda value, and x is here different values. First one 0, second one 1, 2, 3. Okay, so those things we substituted and we calculate. Okay, so that's why cancel is must. 200 into e power minus 0.61, 200 into 0.61 into e power minus 0.61. So why? Because here it is power 1, 1 factorial. 1 factorial is 1 and power 1 is as it is. Next here 2 factorial is nothing but 2, and here it is actual formula 3 factorial. 3 factorial is nothing but how much? 6. So further 6 here we wrote, and 2 factorial is 2, and here 1 factorial is nothing but 1. We didn't write that one. So 0 factorial is also 1. So we can multiply this one with this one. 200 into this one 66.28, 20.2, 4.11, 108.67. So here it is, these are the expected frequencies, but frequencies must be integers. So simply what we can write, this is 109 and this is 66 and this is 20 and this is 4. Okay, so these are the expected frequencies we got it. And here observed frequencies 109, 109. Say exactly 65, 66. Next 22, 20. And 3 here, 4 here. Okay, so which are nearer to that. So that was only, that one only we said. The disadvantage of probability distributions is you may get nearer to the observed frequencies. In some of the cases exactly we'll get that one. Okay, so 4 also we calculated, so 0.626. Okay, that is nothing but 1. Okay, now by since frequencies are always integers, by converting them to nearest integers we got this one. So these are the observed frequencies they gave in the problem, and these are the expected frequencies what we calculated by using capital N into P of X. So this is the formula we used for calculating expected frequencies. Capital N is nothing but 200 into, and P of X is nothing but we used e power minus lambda, lambda power x by x factorial. So this is the one we used. Okay, and we got that exact one frequency and little difference, slight difference, and here again we got exact. Okay, so this is fitting of a Poisson distribution. In binomial also same like this, capital N into P of X, but there it is P of X is nothing but NCX P power X Q power N minus X. This one we applied. Okay, or if they ask specifically recurrence relation means we use recurrence relation for calculating all these things. Okay, next same previous what we discussed as it is. Fit a Poisson distribution to the following data. So x values they give, frequencies they give. So first as usual, first we need to find mean. So that is summation fi xi by summation fi. So this is nothing but we can represent capital N. So capital N is equal to how much we got it, 400. And next summation fi xi is nothing but 0 into 142 plus 1 into 156 plus 2 into 69 plus 3 into 27 plus 4 into 5 plus 5 into 1. So 0 into this one 0, 1 into 156 156, 2 into 69 138, 3 into 27 81, 4 into 5 20, 5 into 1 5, and by adding all those things we got the values here 400. So already in the denominator 400, so these two cancel, then which is equal 1. So this is actual mean. So but as per the Poisson distribution, what about mean? So mean mu is equal to lambda. So for that, here it is how much we got it, lambda value is 1. Okay, so lambda is equal to 1. Now we have to calculate first p of 0 and next p of, so first we calculate e power minus lambda, lambda for x by x factorial, and next we calculated same like as previous one. That's why we wrote here direct one. 147.15 we got it, and 147.15, 73.58, 24.53, 6.13, 1.23. So now we are writing observed frequencies and theoretical frequencies, which are nearer to integers. So here we got it as 147.5. So for that we wrote here 147. 147.15, 147. Next 73.58. So this is 74. And next 24.53, 25. 6.13, 6. Okay, but actual frequencies are this one. So observed frequencies, it means what they gave in the data. So these are their observed frequencies and these are expected frequencies. Like this we need to fit a Poisson distribution. Suppose there they ask to use the recurrence relation. So that one, first you need to calculate P of 0 by using e power minus lambda, lambda power x by x factorial. So this is the one we need to calculate for first one. And remaining all these things we can use recurrence formula. So p of x plus 1 is equal to lambda by x plus 1 into p of x. By substituting different values of in place of x, we will get this. Okay. So these are the different problems in Poisson distribution. Okay. Now next